Hello, this is Bill Ashby. I'm with Maryland Department of Environment Dam Safety Division. And I want to go over how to use ArcGIS Pro for creating watershed shapefiles that will then be used with Maryland Dam Safety's PMP evaluation tool. Before we start using ArcGIS Pro, I just want to talk about some initial files that at least I like to set up, and it's totally up to you. We're going to start on a project that's out in Western Maryland. It's Maryland's dam number 36. So I've created a file 0036, an ArcGIS subfolder, and then projects and then shape files underneath of it. And for this project, I've gone ahead and done a little initial work using USGS's application called StreamStats, and got some shape files to give us a good idea of where we will be working. StreamStats is a good program, good package, but it's not real precise. It's on larger cell-sized DEMs, I think at least 30 meters, if not bigger. And so it's not as precise as we would like to use for our purposes with the PMP tool, but it's a good go-by. So we're going to keep those files close and handy as we go through our new project in ArcGIS Pro. So first thing we do is click on Map, and I am going to navigate to those files that I just talked about. It's on the computer, it's on my desktop, and on the computer, desktop, 036 ArcGIS. So that's the folder that I want to have my project working in. So hit OK. And the project I'm going to call 0036 Watershed. And hit OK, and it creates the map. Now, the first thing we need to do once we've got the map created is to bring in our LiDAR information. Very simply, we go to Map and we add data and we browse for our data. And in our case, along the left-hand side, you will see ArcGIS Online Data. So that's where we want to grab our information. And up here in the search bar, we type in Maryland. And our project is located in Garrett County. And we click Enter, and it'll search for available information in Garrett County. And here we have the digital elevation models in feet. We'll click that and hit OK, and it will load. Now, the challenge with this LiDAR information is it's big. A lot of pixels, a lot of elevation information for the entire county of Garrett County. So we need to now kind of focus in on where our project's going to be located. So if I turn the layer off, I know that Broadford Lake is near Mountain Lake Park. So we scroll in, and lo and behold, there's Broadford Lake. Like I said, Dam 0036 in state of Maryland's inventory. So I'm in here a little bit closer. Let's turn that LiDAR back on, and you can't really see much. It's nice and cloudy, but we do know that this is the general area. So we're going to clip out, we're going to extract just the information that's associated with this watershed from this larger DEM. In order to do that, we're going to use that StreamStats file kind of as a go-by. So again, we'll go back to Map, Add Data, Browse. This time we're going to go to what is on our computer, 0036, ArcGIS, Projects, Shapefiles, and there's our StreamStats shapefile. So click on it, hit OK, and there it is. It pops right up. This is good. Now, why don't we use this shapefile? Well, as I said, this is based on pretty big cells for this watershed. It isn't really accurate around the ridge lines, but it's close enough for us to get an idea of where the ridge lines are. So what we will do now is create a clip file around this file so that we know that we have the ridges taken care of, and we can use a smaller DEM file. But first we have to create a clipping shapefile. So what we do for clipping shapefiles, I'll turn that window off on the right-hand side, is we will now go to the View command, and we're going to go to the catalog pane, and the catalog window pops up over here, and we need to now in the catalog window we need to right-click folders, and we're going to do add a folder connection. And now the folder connection will be associated with the path of where we want to keep our files in our project. So in this case, we're going to do a folder connect. We're doing a shapefile. I want to connect the shapefiles folder. Hit OK. And then what we get to do is, we now right-click the shapefiles. Right-click the folder. No, we did that. Click on Shapefiles, and we're going to create a new shapefile. So we're at folders, click on Shapefiles, create a new shapefile, come over here, a new shapefile. So the geoprocessing window pops up, and we then fill out the information. First off, make sure that it's going to the area we want to go. So let's look to see this PC, desktop, 36, ArcGIS, projects, shapefiles, and we give it a name. Now our name that we're going to use is something fairly simple. We're just going to go ahead and call it DEM clip. So let me go ahead and put it in the name here. We're going to use this to clip the DEM, so it's DEM underscore clip. Okay, it's a polygon, so that's good. Template database, I'm not so worried about at this point, but we do want to come down here to coordinate system, click on coordinate system, and we're going to use the Maryland LiDAR coordinate system. So we hit that. It looks like everything's all ready to go. And so we then hit run. And if you see over in the left-hand column over here, we now have a DEM clip polygon. Now the polygon's empty, so we have to add data into the polygon. So now we make sure that it's highlighted. And we now go up to, I'm going to get out of this. And we now go up to Edit and Create. And the Create Features window pops up. And we go over here and highlight onto DEM clip. And we go to the Polygon tool and click it. Now we can draw the polygon around and make sure that we get bigger than the stream stats folder or shapefile. So start at the north, at least I like to start at the north. Again, it just makes sure that we're outside of the stream stats shapefile and continue on around. And then the last spot that we pick, we will double click. And we have now created the DEM clip shapefile. Once we're done here, the lower two blocks, go down and hit Finish. Now that it's finished, we go up and we save the work we just did and save all the edits. We say yes. All right, so now our clip file has been generated. Now we use that clip file to export the DEM from the overall LiDAR file. And probably the easiest way to do that, I'm going to go ahead and close the Create Feature window. Nice. I'm going to go ahead and right-click the LiDAR file. And near the midway to the bottom, you'll see it says data and export raster data. So it says, okay, that's nice, but where are we going to send it to? Now, this is where we create the data file name. And I'm going to first off browse to, all right, we're at desktop GIS project shapefiles. We're in the right location, but we need to add a name. And so this time I'm going to call it, since we're using the Maryland LiDAR, I'm going to call it MD underscore LiDAR underscore clip. So this is a clipped file of the Maryland LiDAR. And it's a raster image that's, yep. So we hit save, and it's now created. Now, we can leave the output format as default for grid. We look at the coordinate system, and it's the NAD83. We're good. Graphic transformation can stay as default, but the clipping geometry that it's looking at, we don't want to use as default because it's basically the screen. So we now want to use the drop-down menu and go to the DEM clip file we just created. So we click on it, and we don't have to click on the use input features. If we do, we just make sure it stays on the outside. And now you will see the extents of of the clipped or exported file. Now, it's interesting in these values that show up under here with the raster properties. Everything looks good to go, but you'll see the raster size. The columns look good, but the rows do not. There's a red box around the rows. And if you, let's see, where's the image information? It's down here. Output raster data sets have limitations, 4,100 rows and 15,000 columns. Well, the rows are 7,900, so that's a little high. Well, let's just try changing that value to 1.5 and see if that helps us. Not quite. So let's change it to 2. Come on. Change that value to 2. And boom, we're at 39. So we're below 41. We're good. Pixel type can stay as default, and same with the rest of the items here. So we'll now just hit export. and this takes some time. So after this has been created, we'll have a much smaller DEM for just the area around the watershed. And the rest of the DEM for Garrett County is no longer necessary. So once that clip file is created, we're going to remove the main LiDAR file. But obviously you can't do that until the new DEM has been extracted. Now, once this has been extracted, we then go into a routine called the fill. The new image that comes out, did it not show up yet? Should be. Let me turn the other images off. There it is. There are some imperfections in here, and the way to kind of correct the imperfections, especially along the ridge lines, are using the fill commands, or even down here in the valleys too, is to use the fill command. Well, first, let me get rid of the big LiDAR, right-click it, go to the top, hit remove, because we don't need all of that data anymore. We do need this DEM, but we don't need the other data. So now the first thing we do is use the fill toolbox to correct any imperfections. So from that, we go to analysis tool, and we go to the toolbox. And in the geoprocessing window, click on toolboxes, and we go down till we find spatial analyst tools, and click on spatial analyst tools till we find hydrology. And in hydrology, we now do the fill routine. So we click on fill, and the input raster image that we will be filling is the new file we just created, the clip file. So we select it. It gives us an output raster default name of fill of the Maryland LiDAR file. That's fine by us. No real need to have any limits on the elevation. We should go over and check the environments and make sure that the output coordinate system is the same that we've been using everywhere. And we can go ahead and hit current map because it'll come up as NAD83, which is good. We can now either, if you want to go back to parameters and hit run, then we will be filling in any of the imperfections in that file. Once the imperfections have been filled in, the next thing we need to do is figure out each of the individual little cells in that file. Oh, see, the fill has already been created. Let's go ahead and turn off the clip file. We don't even really need the clip file anymore, but we'll keep it on hand for now. We do need the filled in file. It's the better representation of what's going on down here, especially near the dam, because it'll fill in all of the holes down there, and it's fine. But now we need to figure out the direction that each cell in this DEM is flowing. So we will now back out of the fill tool, and I'm not sure why it dropped to that, but we'll go back to the geoprocessing window, and we now need to figure out the flow direction. So get down to flow direction tool. Now, our input surface raster that we use for figure out the flow direction is the fill file we just created. And the output, we can leave it as flow direction. That is fine. We don't have to force any edges to flow outward at the edges because we know that we're well inside the watershed. We're not really worried about the edge files. Output drop raster, not too worried about it. The flow direction type is kind of critical, but it's also D8 is typically the default. D8 refers to, and again, if you hold your mouse over the information button, there's 8 directions of how the water can flow. To the east is considered direction 1, southeast is direction 2, south is direction 3, and so forth, around like a compass, if you want to call it that. So D8 is fine for us. Do you want to go back to environments and check the output coordinate system? And again, let's just use current map, NAD83, we're happy. And go down and hit run. It takes a little bit of time to process, but it does figure out which direction each one of the cells in this raster image are now flowing. And once it's done, it will pop up on screen just like that. And again, you get to see all these 8 different colors. Gray is everything that's flowing to the east, and so forth. East, southeast, south, southwest, west, and so forth. Now we have how each of these cells are flowing. We now need to take these cells, and each cell flows into the next one downstream until it finally gets to the last one. And as you get closer to the bottom, they all accumulate together in the river. So now we do flow accumulation. Excuse me. So we back out, hopefully there we go, geoprocessing. We now go to the flow accumulation tool. We click it, and the flow direction file that we use is the one we just created, flow direction. The output file is the flow accumulation file. The default name is fine. No reason to change the input weight raster or the float, and it was a D8 file that we used, so that's fine. Let's go up to environments, make sure that the coordinate system is set at NAD83, and we hit run. and it'll create flow accumulation tool or raster. Now, the output to this is interesting because it's, if you're not familiar with flow accumulation, it's values of 0 if there's no flow, if it's the last cell in the top of the watershed, no flow is getting to it. And it gets down to very large numbers where all cells are flowing to it. So the values go from 1 or from 0 to a very large amount. And you'll see here in a second, once it's finished processing, that it'll either be black or white. I guess some gray in there too, but it's mostly just black or white. And as it finishes, any minute, it's adding up each little cell and sending it down into the valley. And so it looks like it's done, and there's our flow accumulation raster image. And if we scroll in here close, you can see that these cells here have a lot of flow accumulation to them. These do not. And you can see it ranges from, almost 2 to the power 7, the white values down here. If we clicked on one of those values to get information on it, you would see how many cells actually flow to it. I'm going to try this. We're going to click on the symbology. And instead of having stretch, I'm going to do classify. And I'm going to do basically just 2 classes. Okay. Why didn't that work the way I wanted to? Discrete. That's where I wanted to do classify. I'm not sure why I can't get to that. Well, I'll tell you what, I apologize for this. Let's just go back to stretch the way it was. We can still get plenty of the information we want. But what I like to do is to, I'll toggle the flow accumulation on and off. Let me turn this one off too, because I can see where the embankment is for Broadford, and I can see where the spillway is, and that's based on the topographic map and world hillside that I have as background images. So I know that all of the flow is coming through the spillway. It's not okay. We work in dam safety. We know the water is actually going through the principal spillway, but as this is being modeled, the flow is actually saying that it's going through the emergency spillway. We've filled in all of these voids behind here. All of the cells upstream are now saying that they're coming through the spillway, that's fine by me. I get that. So we know that the spillway is in this location. So I'm going to zoom in here a little bit closer to the spillway. Turn that file on, and we know that the flow is coming through here. Okay, that's good. Now, in order for us to create the watershed, we have to tell the next tool that we use exactly where that we're going to collect all of the data for the watershed. All of those cells do come to this point right here, but what encompasses all those cells? Show us the watershed to that cell. We have to do that by first off creating a point down here. And similar to the way we did our shapefile, we now go to View, Catalog, and before, when we created the shapefile, this time we right-click onto the shapefiles folder. That's where the data is being held. And we go a new. It's a shapefile, but this time the shapefile is not a polygon. If you look over here on the right, it's a point. And again, we make sure that we're in the right location. So let's navigate to the proper folder, hit OK. And the name we give it in that folder, we're going to call study point, STUDY underscore PNT. Okay, that's fine. And what type is it? It's a point database. We're okay there. And so now we have, and we make sure that it's in the correct coordinate system. It is NAD83. And so now we've created study point. We hit run, and you'll see over here study point pops up. Okay, that's all good. Similar to the DEM clip file we created, if this is an empty database or an empty shapefile that we now have to give information to. So we right-click study point, or we highlight study point, and we go to the edit, create, and since we've highlighted study point, it comes up here in the create features window. Click on study point. It says, okay, let's create a point in that file. So we click on, before I do that, let me turn this off quick. Scroll out just a hair, turn it back on, off, on. So yeah, I want to pick a point right about here. So I'm going to scroll in here, click on point, come down and select my point. I'll do this point right here. We have to make sure that we're right on top of one of the accumulation cells. So we'll pick that point. We're good with that point. It looks nice, nicely located. We'll click finish and save. Save all the edits? Yes. And now our study point is physically associated with this accumulation file. So we are done. Get out of that. So now we have a point in this accumulation file to show us how many cells have accumulated to here, and the limits of the cells that accumulate there, which is the watershed. Excuse me. So now we get to create the watershed raster. So go back to geoprocessing, the geoprocessing window. Under hydrology at the bottom, we do watersheds. And so what was the flow direction file? Because it needs to know how everything was flowing. So we find the flow direction file, flow direction, very good. The point data file, input raster or feature point data file. So we scroll down, we find study point. The pour point field, don't really need to change that. Now it's giving us a raster flow name to use. We could go ahead and call it watershed flow, and that's probably good for the raster. Remember, a raster is a raster image. It's not a shapefile. So let's keep that as the same as watershed flow. Now let's also go to the environments, make sure our output file is the current map, NAD83. Happy with that. And we hit run. Now this may take a minute, because it's going back through that flow direction file and finding every little cell that is going to it. And we had to use the flow accumulation file to pick the point, the study point, so that the watershed routine would be more precise with where the watershed's going. Okay, well, we have information that's popped up. It's black. If you notice, all the values are 0. I'm going to go ahead and turn off flow accumulation, and there's our watershed. Now, again, if you don't really like the colors, which I don't particularly, I can go back to symbology, and I'm going to create, I like blue. So it's now blue. And I can also go to up here to the top, where it says raster layers, and change the transparency to something like 50%. maybe even lower. Let's do 25%. No, other way, sorry, 75%. And you can see a nice shaded area of our watershed. That's pretty good. While we're here, I'm going to go ahead and turn on that stream stats file and show you the differences between them. So if you see, like in this area here near Deer Park, you can see that the stream stats found a point here and then a straight line from here to here and missed the ridge line that actually exists along here. That's why we prefer using ArcGIS for our watersheds as opposed to stream stats. Okay. All right, so now we have our watershed delineated, but now we have to turn it into it's a raster image. So we now need to turn it into a shapefile, which is not hard at all. Let's go ahead and close these windows. We're going to go back to the analysis tool. And under geoprocessing, let's get out of spatial analysis. Under geoprocessing, in the toolboxes, let's find conversion tools. So we're going to go to conversions. Excuse me. In conversions, we look to do something that's from a raster, and it's going to raster to a polygon. Pretty simple. All right, so what's the input raster image? What's that watershed file that we just created? Good. Field, we don't need to really change anything. This time, for the output poly feature we're going to create, we make sure we go to where we want it saved. And in this case, let's go back to my computer, desktop, this PC. Come on. Desktop, 036, ArcGIS, projects, shapefiles. This is where I want it to live. And then I give it a name. And this time, remember how I called it 0036 stream stats? Here, I'm going to call this 0036 underscore ArcGIS underscore watershed. So this is, and it's, all feature classes is fine, but we've now called it the 0036 ArcGIS watershed, not the stream stats. We hit save. Other things, again, make sure the environment is set for NAD 83. And we hit run. And boom, there we are. We now have a shape file for the for this watershed. We can go ahead and get rid of all of the rest of these if we want. And for your information, we look in our projects shapefiles folder. And here we have ArcGIS watershed shapefile and all the other ancillary folders that need to go with that watershed shapefile that can then be used right into the PMP evaluation tool that Maryland Dam Safety is now using. So I hope you enjoyed the little dog and pony show here. And if you have any questions, you can always contact our office, and we're always glad to help out. Have a great day.